Hello everyone, this is Mohammed Saif from EC Department of RV College of Engineering. Today we will be programming STM32F407VGX board using STM32CubeMX for toggling the LEDs with or without push button and also interfacing of 7 segment display. So to program STM32 board you require these three softwares. At first we'll program our STM32 board to toggle the inbuilt LEDs. So for that you have to open STM32CubeMX, then go to the access to board selector, go to the commercial part number and insert your board name, that is STM32F407. Select this board and select again and start the project. Go to the pinout section, clear the pinouts, go to the system core, select system, select as serial wire, go to the RCC, select high speed clock as crystal. Now come back to your board. For toggling of LEDs, we'll use inbuilt LEDs of STM32 board, which are internally connected to the port D, pin 15, 14, 13 and 12. We'll set this pin as a GPIO output. Click on the pin and set as GPIO output. So once we select this pin as a GPIO output, go to the project manager, insert project name. Once you insert your project name here, select your project path to be located and then go to the tool chain and select MDK RAM and click on generate code. Open project. This is Skill Macro Vision software. Now go to your application user, click on main C. This is the main code. This is the header file to be included, and these are the functions written by the STM32CubeMX, and those functions should be initiated here, and the main code should be written within the while loop. So for toggling of LED, I have used a built-in LED connected to pin 15 port D. You can give any pin like pin 15, 14, 13 or 12 because we have selected all these 4 pin as a output. At first, I will set pin 15 of port D as high and I will give some delay of 1000, that is equivalent to 1 second. Then I will reset pin 15 as low and I will give the same delay, and this process is get repeated again and again because this is written within the while loop. We'll copy this code from here and just write this code into your kill macro vision within your while loop. Once you write the code, save the code, click on your target file, option for target, select ARM compiler as version 6, go to debug, settings, flash download, check for reset and run. Click on OK and OK. Once you're done with those things, Go to compile, zero warning. Now build it. Now click on load to download the code in your STM32 board. Now I will show you how to blink all the LEDs, that is 4 LEDs, one after another. So this is the code to be written. At first I will blink the LED connected to pin 15, then pin 14, then pin 13 and pin 12. And this process get repeated. We'll just copy this code and run it in a kill macro vision. Now we will see how to interface 7 segment display. As you guys know that 7 segment display has 9 pins. In that, one pin is for common ground, then remaining is to control the specific LED of 7 segment. Because of that, we have to set 8 pins or 7 pins of STM32 as GPI output in our STM32CubeMX. We'll follow the same procedure that of the previous experiment. We'll select 7 pins from port A. So PA1 has GPI output, then PA2 has GPI output. Similarly to all other PA. This PA4, 5, 6 and 7, and also PA3 also. So these 7 pins are set as GPI output, and for this specific 7 pins we will be connecting pins of our 7 segment display. Now go to the project manager, insert your project name, choose your project path and select IDE chain as MDCAM and click on generate code. For 7 segment code, you have to write the code in this manner, where you have to write the code for displaying 0, then 1, 2, 3 and similarly till 9. So I mentioned delay of 500, which is equivalent to half of the second. As you can see, I have mentioned GPIO A and pin 1, 2, 3, 4, 5 and 6 has set mode and GPIO 7 has reset. So it will be glowing all the surrounding LEDs of the 7 segment except the middle segment. You have to consider pin 1 has A, then 2 has B, 3 has C, D, E, F and 7 has G. Then easily you can program for displaying any number. Now we'll just copy this code and run it in your kill macro vision. Now follow the similar steps that of the previous experiment. Go to your target, select version 6, debug settings, flash download, reset and run. Save the code, compile it. Now build the code. Now we will interface the LED based upon the push button. System debug as serial wire, then RCC has high speed clock crystal. Now coming, we have integrated push button connected to a PA0. So we'll be setting this PA0 as GPIO input. Then to toggle the LED, we'll use all 4 LEDs. I am selecting all the 4 LEDs, but you can select any one of the specific LED or any specific pin. Go to the project manager, insert your project name and select your location. Select MDK arm, then generate code. Go to the application user, main C. So for toggling of the LED, we have to write this code, where at first we'll check the status of the pin, that is button connected to that specific pin, GPIO A and pin 0. If it is set high, that is the button is pressed, then it will glow the LED, or else it will turn off those LED. So I will be glowing 2 LEDs that is connected to pin 13 and 15, and similarly here I will be turning those LEDs off. We'll just copy this code and run it in your kill macro vision. Follow the previous steps.